Is there a planet better than Earth? Technology advancements in recent years have made it possible for us to find numerous exoplanets and moons that are strikingly similar to Earth. A telescope was constructed specifically to gaze at a certain region of the Milky Way to look for exoplanets. During its lifetime, the exoplanet hunter viewed hundreds of thousands of stars and found thousands of exoplanets. Have you heard about the K-18 planet? Stay tuned to find out about this. Welcome back to Space Gateway. One of these, known as T-Garden b, was discovered in 2019. This super-Earth orbits an M-type star at a distance of 0.0252 AU every 4.9 days. With a distance of 12.4 light-years, the T-Garden star is one of the nearest stars to our solar system. Despite being 10 times less massive than our Sun and having a temperature of just roughly 2,700 degrees Celsius, the red dwarf can nonetheless support its two planets with heat. The two exoplanets are only marginally more massive than Earth and resemble the core planets of our solar system. Both of them are in regions where liquid water can exist, but T-Garden b appears to be more promising. In fact, T-Garden b has been given a score of 0.95 ESI, making it the most Earth-like planet found to date. This is because there is a 60% chance that the exoplanet has a surface environment with temperatures ranging from 0 degrees to 50 degrees Celsius. And if its atmosphere is similar to Earth's, the surface temperature would likely be similar as well. However, T-Garden c is farther away from its star with an ESI score of 0.68 and only has a 3% chance of having a warm surface temperature. The world's predicted temperature would be roughly minus 47 degrees Celsius if its atmosphere were more like Mars. T-Garden b and c are tidally locked to their star, and a thin atmosphere might disperse heat and cold across the boundaries between dark and light, although researchers are unsure of the composition of the two planets' atmospheres. But that's not all. According to scientific estimates, atmospheres with densities between 1 and 17 times greater than those of Earth's might permit the presence of liquid water on the surface. The discovery of its most promising candidate had just been made in a planetary system that offers some of the best candidates for extraterrestrial life. There are at least 4 planets in the TOI 700 planetary system, and 2 of them are located in the star's habitable region. The two TOI 700E and 700D, both of which are rocky and have masses akin to Earth's, are the most promising. In comparison to TOI 700D, which has an orbital period of 37 days and is 105% larger than Earth, TOI 700E has an orbital period of 28 days and is 95% Earth's size. More than 1.5 billion years have passed since the TOI 700 system was formed, more than enough time for life to develop and fill the thin space between the planet's surface and its atmosphere with a diverse biosphere. The average temperature on TOI 700E and TOI 700D would be significantly higher if they had an atmosphere. Scientists believe that there may be other planets beyond TOI 700D that are potentially habitable, and if we were to one day find life on any of these worlds, we would probably hope that it resembled that found on Earth. However, is it theoretically possible that similar life forms could exist on other planets? Like gravity, evolution is seen as a universal law of nature. Due to a phenomenon known as evolutionary convergence, where unrelated species can evolve comparable adaptations to similar environmental difficulties, the principles of evolution discovered on Earth can be applied to other planets. Any alien planet must have had a simple beginning, and many of them could have kept it that way. However, if any of these worlds evolve complex forms of life, it can only happen if favorable alterations are kept and bad ones are thrown out. If you want to go to these planets, then subscribe to our channel. Even on our own planet, there are species known as extremophiles that can live and thrive in conditions that would be fatal to other types of life. These organisms could serve as models or examples for other odd life forms that could exist on other far-off planets. What if we changed our approach and looked for something else? Up until now, the search for extraterrestrial life has primarily concentrated on planets planets that resemble Earth. It's possible that a planet with exotic life forms has a unique and varied collection of planetary properties that distinguish it from other, more commonplace worlds. Extremophiles may need these qualities to survive in extremely cold temperatures. The Haitian planet is a novel class of exoplanet that was only recently identified by astronomers. Despite being significantly different from Earth, these planets might be able to sustain life. The habitable zone is larger on planets than it is on Earth because they have hot ocean-covered surfaces and hydrogen-rich atmospheres. Within the next few years, according to scientists, it's possible that the finding will lead to the discovery of life elsewhere in the solar system. The oceanic conditions on ocean planets, which can be up to 2.6 times larger than Earth and have air pressures approaching 200 degrees Celsius, might be able to host microbial life similar to that found in the oceans of Earth. If one such planet is a landmark, one would expect to find water on its surface. Out of all the exoplanets found by Kepler in the habitable zone of stars, K18b is also the first planet with water in the quest for potentially livable alien worlds. Following the planet's initial discovery by Kepler in 2015, its makeup has been investigated by various telescopes, including the Spitzer and Hubble space telescopes. Kepler primarily found exoplanets using a technique known as the transit method. In essence, it means that we can detect the presence of planets by noticing a minor dimming of the star's brightness when a planet passes in front of it. We can learn vital details about the size and orbit of the planet from the degree and duration of the dimming. The detection of an extrasolar planet's transit is extremely difficult, though. For instance, because Earth's diameter is just 1/109th that of the Sun, its passage through the solar system would only reduce the Sun's output of light by 0.008%. According to recent research from Georgia Tech University, the planet's spin and axial tilt have been examined. It was discovered that the planet's tilt is steady, like Earth's, suggesting that Kepler 186f likely has predictable weather patterns and seasons as well. In fact, due to algorithmic error, earlier Kepler results that were disregarded as potential Earth-sized exoplanets are now being rediscovered. Slowly but surely, these false positives are being re-examined in conjunction with information from other telescopes. Kepler 1649c is one such planet. Astronomers discovered another exoplanet with ideal circumstances for life in mid-2020 while combing through old Kepler data and comparing it to fresh data from the Transiting Exoplanet Survey spacecraft, or TESS. So what do you think about these planets? Let us know in the comments section. Also, support us by clicking the subscribe, like, and bell icons. Refer to our other amazing videos too. Bye!